Okay, it's Tuesday, and for Unit 13 here, um, we're going to be covering um, time complexity and big O notation. I imagine a number of you have seen time complexity, big O notation, probably in data structures class, you covered it, if not even in Java 2. We're going to look in more detail, and then next week, we're going to look at what are called P versus NP problems and NP complete and some of the more theoretical components of time complexity here, showing that if you can solve one type of problem, you can solve in polynomial time, you can solve a whole bunch of problems in polynomial time. But this week, because it's Easter, we're just going, you'll do the QQSP, there'll be prompts. I didn't put as many prompts this week in here. So the prompts are there. And then there's the learning activity. There's no assignment this week here. And for the learning activity, it's a little more independent. I'm assigning you in teams of 3 here. But again, you can kind of, I want you to share the document, but there's not a whole lot of interaction here that's required here. So what we're going to look at is these big O notation, how we measure how long a program could run here. And we'll look at it with starting with the shortest programs, log n. Well, there's actually constant speed programs, but we're skipping those. Log n times, so that's like a binary search here. And what we want you to do is come up with a problem or algorithm that runs in log n, select a language to implement that in, put the code in here, time the code and run it, and then graph the results. And we want to run it for multiple examples so we can see these results. And AI can certainly help you with this. So for example, log n is like a binary search is a great example of a log n here. So if you, and again, with these, you can ask AI for examples if you don't know of examples. Again, in your mind, you're probably thinking binary search anyway, because again, if you start with 100 items, you can search through it without 100 guesses. If it's ordered, you can search through it in under 10 guesses there, just by dividing it in half each time there. So again, example would be you'd select binary search. And again, each student doesn't have to do the same algorithm, although they certainly can here. Each student should do a language here. So I either want I don't want duplicates, so I don't want the same 2 students doing the same problem with the same language. You can all do the same problem if you do 3 different languages here. That would be fine. Or you can all do it in Java and do 3 different problems for that. And then write the code. And again, I should write the code. And then have it run like for a bunch of different examples. In this case, an array of size 10, 100, 1,000, 10,000, 100,000, and 1,000,000. You could even go a little larger than that if you wanted for this. And then time it. And again, you can have your code just time the runnings and run these things here. And then your code will probably produce a listing for array size 10, it took this long, array size 100, it took this long, and whatever. And then you can just graph these results. I'm not sure if AI can graph results like this yet. I haven't tried. I'm just so used to doing it with a spreadsheet here. So again, if we have a sheet, you can just enter some values in here and then just do and the amounts, 10, it took this long, 100, it took this long, copy those in and do a graph, do an insert chart there, and that should do it. So do that. Oops, this should actually be student 3. So it should be student 1, 2, and 3 here. And again, we want to do it for problems up to So we want to do a log n log n squared. Actually, and any polynomial n cubed or whatever is fine there. And then 2 to the n here. And then yeah, and I skipped the factorial, which is the highest one for this. If we look at the prompts, I did include just a little graph in there. Let's see where that is. It kind of shows this as, we want to kind of see this sort of stuff. So with like log n, the time will almost have little growth as you get the number of elements longer. And then order n will have a nice straight line here. N log n will start curving up. Like n squared or n cubed, any polynomial time will increase pretty fast, but and then 2 to the power n or n factorial will go up really fast for this. So again, just go through the learning activities and do that. For some of these activities, to really test these out, especially if we're creating like an array of 10 random numbers, we can look at, there are different types of operations here where you could run it for the worst case scenario or the best case scenario and stuff like that here. And we actually see, like, when we sort, there's I like this example of sorting here and sorting algorithms. We can see if it's randomly or nearly sorted or reverse, the way you select these random elements will certainly change which algorithms perform and how fast some of them perform here. So in your activity, if you want to have your code like run each example 10 times and average the time, that would be great. But you don't have to do that. So that's just a bonus thing here. You probably don't want to do that when you get up to like 2 to the nth, because I think that's going to take a fair amount of time to run those problems here. Okay, so I'll assign you to teams. You'll do this. Whoever gets here first, the student 1, start doing the student 1 stuff, and then share the documents with student 2 and 3, and the other students can fill in. And again, there's no reflections on this because of Easter and stuff. So you just have to do your own part of this. Okay, the other thing I just want to mention over break, there's no assignment, but I do have the final project available here, so you might want to start thinking of that over break. The final project is kind of a two-parter. It's a final paper and a final presentation here. As far as what you can do, as far as the final paper goes, there's a couple different options. You can do like a traditional research paper where you select some topic we've covered in the course, find some peer-reviewed articles, and kind of do a summary of what's the current research in this area for this. And so if you want to do a more like, again, theoretical research paper, that's fine. If you want to do a more applied things, you can explore some advanced programming techniques that we talked about, maybe generics or the asynchronous programming or tail recursion, something like that. Those are some examples. And then create a kind of a tutorial paper describing what this is. Give clear explanations of the techniques and example code from this stuff. Now, no matter either way you want to, we need at least 3 high-quality sources for this, and we need it in AP style. So even if you're doing this tutorial, it still has to follow that 3 high-quality sources, but they don't have to be peer-reviewed articles, and it has to be in AP style. The other thing is, maybe we've talked about a number of programming languages. Maybe you want to take a deep dive in one of these new programming languages like Go or Rust or something like that. So I don't want just a beginner's tutorial on how to write hello world in this language. I want you to really try to highlight some of the advanced or unique features in the language and include sample codes to code to demonstrate that. So you have to do one of those. Well, and again, something in that area. You can talk to me if you have a different area. So again, I want to, you have a pretty broad choice here for this. Now, one of our problems right now is that AI can write this paper for you. And so you can have AI help you brainstorm, research, or edit your paper, but you must be familiar with everything in your paper. And how am I going to test that? That's what the presentation is going to be for. So, you can't submit a pre-recorded presentation. It's got to be a live synchronous presentation. There's a number of times you can sign up for. There are 4 different time slots for some on Zoom and some in person here. You have to sign up for one of these slots or times to do your presentation. You're expected to give a 5-minute presentation, and then I will grill you for 5 minutes on your paper. Okay, maybe I won't grill you. I'm not really good at grilling students, but I will ask you questions for 5 minutes. And other students can, but I will certainly have read your paper and will ask you some questions about your topic. And again, what I'm basically trying to make sure you did is you're familiar with I'm not going to ask you really hard. I'm going to ask you about stuff in your paper there and see if you understand it and can explain it. Again, because if you're using AI to write your paper, you might not understand what AI is saying. So I'm going to make sure you are understanding what AI is saying for this. You might say, well, Tom, if I gave a 5-minute presentation, obviously I knew what the paper was about, but I also believe that you could have AI help you write your presentation. And I've seen too many students just reading the presentation words up on the screen and not really knowing what they are. So, any questions on the final project? Okay, so good luck on the presentations. I'll have the teams posted soon. Let me stop this recording.